This is Jim Morentz of the XchangeCore community, and welcoming all of you today. And what we're going to be doing is first welcoming you from everybody around the country. And then what we're going to do is take a look at how Web Service Data Orchestration really drives content in the value, it provides value to decision making. And then introduce a couple of other things. Our new release of XchangeCore, and how you can begin to use XchangeCore without having to do an installation. And we'll talk about that at the end. So we'll start off and we're going to level set so everybody understands what Web Service Data Orchestration is, and look at some of the fundamental values that exist and why there is such increased functionality through orchestration over today's other popular solutions. And then talk about the content packages, how that drives common operational data through a set of information exchange standards to support decision making. So without any further ado, let's get started. First of all, our level setting. What is Web Service Data Orchestration? Well, orchestration is the process of integrating two or more applications and/or services together to automate a process or synchronize data in real time. That we're doing. And all those components are part of what we're going to see that XchangeCore does. Specifically, 5 different capabilities. The first one is translate data. Translate web service data into a common format. Web service is a big, popular new way to share information, new over the last few years. Share information, some see it as the answer to all problems. Doesn't really work that way because there are lots of things that are not in web services. Maybe 10 years from now, that will be the proven way to exchange information, but I'm also betting 10 years from now, there's another way to do it. For right now, you need to support multiple ways of getting disparate data into a common format. You might be able to translate a web service, or you have to transform a non-web service into that common format. Then, and those other things, anybody can do those if you work really hard. Now we start to get to the real core of it. It's I get that data. I don't just want a big pile of data. I want to package data into content packages, we call them, that are going to help me know that this is relevant data for those who consume it. Absolutely critical component to the whole orchestration process. That all has to be done securely. There have to be agreements between providers and consumers to make certain that only authorized applications are getting the right information. And then lastly, it better be happening at the same time. It has to be synchronized in real time so you are able to make certain that every application is getting an update so that you have consistency and currency of information sharing across the entire Exchange community. If you don't have that, you have disparate information, which is where you started. And we want to get away from having different information held by different people at the same time and move ourselves to the point of having synchronized data of common information all in at the same time across a whole bunch of different decision-making applications. That's the fundamental value, pinpointing exactly what data each decision maker needs and making absolutely certain that it's there, available, synchronized in the application that they want to use. So let's drive down this a little bit more, because what we have to do is answer critical questions and eliminate the garbage. Because if you've ever walked into an emergency operations center during an emergency, there is way more garbage information than there is valuable information. Because the whole role of the emergency operations center is suck everything in. Making sense of it is the problem. 2 examples here. Can you imagine, and these are not completely impossible examples, somebody says and has the information ready to say, Governor, Patrolman Hicks has been on his post for 10 hours and needs something cold to drink. Clearly an inappropriate piece of information to be providing to the governor. In the same way, go out into the field and tell the incident commander that FEMA has 3,000 bags of ice in a cold storage warehouse 1,100 miles away in Milwaukee. Absolutely valuable information, but not for that incident commander. You're talking an entire logistics team that needs to know that information. Getting the right information at the right level to the right people is what we're talking about, and getting rid of garbage and making certain that you do not want data to provide this kind of information, because that's what data does. It gets composed to provide information, as you see there. But we recognize that it often does. And you've heard about common operating pictures. You probably even have one. Well, some people think that this is the best way in the world to accomplish this task. And it is a great idea, because you are going to need a common operating picture. But the role of the common operating picture is visualization. It's not to collect the data and show it to everybody at once. Because practical execution of that common operating picture leaves a lot to be desired when it's used to make critical life-saving decisions. As you see from this map, great common operating picture taken from a real common operating picture. And you got weather, you got locations, you got little asterisks there. I've got hazardous materials sites. Well, that hazardous materials site sitting out there in Western Virginia, wherever that is, totally irrelevant information to whatever those red dots are up around Washington State. Totally irrelevant. Nice picture, but it's only if you are going to be supporting a decision that says, gee, do we have enough happening in the United States for today? And that's because common operating pictures are for uncommon purposes. I've got decisions to be made at the strategic level, and that map might very well be useful at a national level. But if I'm trying to manage an incident, and that's not helpful, and if I'm going to be seen on the scene of an incident, that's not going to be helpful. Strategic, management, tactical, 3 different levels of uncommon purpose that we're trying to jam a common operating picture into. Federal, state, local, exactly the same way. Clearly, you're not going to have the same view of your data at each one of those levels. Push it down a little bit. A county, a city, an agency even are going to have different perspectives necessary. And that agency and its division and a unit that might be out on the field, whether it's a public works unit or a health unit, they're going to have a different requirement for what they want to see and know about an emergency than any of those other names on the map there. You must have the data available, though, to answer questions from any of these operations. So now I'm sitting there saying, okay, I need to answer any question here, but I can't answer it by giving them a single common operating picture. And I certainly don't want to have to sit down, write a report, or do a whole bunch of analysis on a computer screen any more than the person who requested me to give that information wants to wait for me to do it. The whole role then becomes one of how do I make effective information exchange? And there are some basic principles on which XchangeCore was built and that exist today. That one view of incident content, and I'm going to talk content, can't be all things to all people. And it absolutely cannot include information unrelated to an incident. That is just creating a risk. And our whole role as emergency management professionals is to minimize risk. A second basic principle is that if you want to give different decision makers a view, their own view of an incident that's going to be valuable to them, then you have to have a common set of standardized data. Because, go back to that picture with those 12 different levels of understanding on there, from strategic down to a unit level, if you don't standardize on the data, you're not going to be able to have data to answer any one of those questions. But then it's more than data. You have to manage the content. Manage the content so that you compose the data into the right view in any one of those levels of decision making and into their own chosen application. Because we've already lost the battle of everybody using the same application, whether it's from the federal government trying to invent an application and push it on down, doesn't work. Or whether it's the commercial industry out there having a dominant player, doesn't work. You got a couple dominant players and 50 smaller companies. I can track you to 250 different types of data format available at any time for anybody to put in their common operating picture. And I've had quoted to me that if you actually just want to go to GIS information to put on that common operating people, you can choose from 90,000 different data layers. Nothing going to be common about that common operating picture. Another basic principle that if you want to allow decisions that are based on collaboration, which I would hope everyone would want to do, then you have to enable two-way communication. You have to enable sharing back and forth so that one decision maker has their special view, can share that information with another decision maker in their own view. And that second decision maker can say, and here's how I've added to, supplemented, or increased the value of this data, and you, the first decision maker, get it back. Each of them using their own application. And then the last of the basic principles of information exchange is that the goal is exchanging common data. Many different decision makers, anywhere, in any organization, that if you can focus on that common data, you're going to understand how best to put it to anybody else so that it's seamlessly composed into the exact view in their application. And so that you've provided the data to each one who needs it to make their own decision at any of those levels that we saw earlier, from a unit all the way up to strategic planning at the federal level. If you can achieve that, then you actually have achieved information exchange. So, people have been trying to do this for a long time. Why does Web Service Data Orchestration give you increased functionality over some of the ways that it's done today? Well, let's take a look at it, and we're going to listen to one of the experts in the field. A gentleman named John Contestable at the Applied Physics Laboratory at Johns Hopkins University, an internationally renowned thinker on this type of analysis and movement of data. One of the things he says is that we could achieve interoperability at this data level, which is the way most systems look at it today, by connecting local, state, and national data sets across agencies and disciplines. Like that. However, that's going to result in a multitude of interfaces between various systems. And many of those systems are proprietary. They're legacy, meaning they're not the nice clean web services, and they are often firewalled. So John goes on to suggest that this is more like what you have in the real world. It's a complex, complicated deployment of multiple applications, all trying to make sense out of the same set of data. So somebody thought of that common operating picture, and they said, oh great, let's pull all that information into that common operating picture so everybody sees the same thing at the same time. And yes, there's a user-defined common operating picture, which gives me all that data, and down the left-hand side I have seen as many as 500 different data choices that I can pick to prepare my own user-defined common operating picture, the chances of me picking the same ones that anybody else has picked in order to understand this common view of the incident, virtually impossible. Let's say highly improbable. So, the problems that exist in only using a common operating picture. It's not to say it's not valuable. It is absolutely an incredible and component of your complete picture. But you can't just use the common operating picture as the way to dump all this data together, or you end up with garbage. The problems inherent with it is that it requires to have a new software application. You may already have a common operating picture, so it may not be new, but it is an independent software application. When in fact, in a major incident, that data comes from many other places. Those many different connections are not going to deliver you managed content. They're going to provide a stream of information you have to figure out. In a larger incident, there are going to be sharing agreements and the volume of content that you are going to have to deal with. And thirdly, on a technical level, it's essentially one-way sharing. You're at the wrong end of the fire hose of information. And for you to share back with anybody who's provided information, you're going to have a soda straw to shoot your information out to them and see whether anybody can pick it up. So you get a fire hose and you've got a straw that you're shooting your information out at them. It's not a orchestrated set of data. In addition, some percentage of the time, and I'm going to suggest that it's not a reasonable percentage, you're answering the wrong question because the common operating picture is not adapted for the operational needs of the user. You saw those 12 different levels of from strategic to unit. Configuring a common operating picture for those 12 levels, plus all the different roles and missions that are contained in each one of them, makes for a difficult problem. On the other hand, the user then becomes responsible, that user-defined operating picture I mentioned, for creating their own picture of the specific mission that then has little chance of being common to the others making related decisions. So what's Web Service Data Orchestration do? And how does it fit? And where does it fit into this world that we live in? And I'm going to go back to John Contestable. He says that a more artful approach, using these networked architecture that we have today, web service and non-web service, would be for the data down there to publish once to an integration tool. Agencies and jurisdictions in various disciplines who need that data could then look at the integration layer to see information that's already fused together with other pertinent data sets to form a more complete operating picture at the data level. Where you display it is irrelevant, whether you're using ArcGIS or Google Earth or OpenStreetMaps or putting it on something else, that viewer is irrelevant. What John is telling us is this integration layer is where you have to have the information fused. Thus, interoperability is achieved at the integration layer by connecting various tools at that layer to one another. This results in only a few interfaces between a handful of key integration tools. Those tools can be standards-based, open architecture, and secure in nature. So it's that integration layer that John challenges us to use to solve this problem. Here's his depiction of it. Data across the bottom, federal, state, local, anybody you got down there. Presentation layer, that's somebody's common operating picture. That's an ArcGIS Online, or that's a Google Earth, or somebody else's picture. How do I get from there to there? Well, I don't want that mass of lines going from each one of those dots up in the presentation layer down to every single one of those pieces of data. But rather the integration, it says middleware there, we call it Web Service Data Orchestration because it does more than just bring the information together. It's going to orchestrate data from all these different types of sources, from dispatch systems and GIS models and resources and sensors and all the rest. It's going to orchestrate, as we described before, translate, transform, synchronize, compose into those data packages. That's what's happening at that Web Service Data Orchestration, which is what XchangeCore is. So we have it on very good authority from John Contestable and the whole set of research that he's done over these last decades, literally, making certain that this is the way the best information is going to be brought to bear in an emergency. So let's drive down a little bit more. Nice pictures, but orchestration means dynamic content, how I'm going to work across that XchangeCore layer of all those different types of data by packaging common operational data. We'll go through this quickly because you've probably seen it before, but we can't get beyond it because if the goal is to exchange information, what are we going to exchange? Basic set of information here that has stood the test of time because out of this common operational data, I can compose any set of essential elements of information that are what decision makers need. What is it and where is it? What my problem is and the location, the geospatial view. Who's in charge? My command structure or emergency support function. Who's going to be running this emergency? And who should know? Where are those alerts from authoritative sources, knowing who has received the alert and who's responded to that alert? What's the impact? How do I understand the environment around this incident right now? By sharing sensor information or cameras or imageries or models of what the future impact would be. What's the response? What resources are employed? Operating procedures are being followed and tasks being performed. And then finally, orchestration helps answer what's happening now. Situational awareness, this is where the common operating picture comes in because it's the way you view all of this other information. And it's provided in shift change briefings, being able to bring statistics to bear to tell you what's happening now. And then the all-important, what's planned next. Future action plans, resource allocation, tactical response, forecasts of impacts, all those components, all those things are part of the information that you need to run an emergency. And how does that all come together? Well, it starts out in disparate pieces of information, and they're going to start flying together. You're going to have incidents arriving. You're going to see command information arriving. You're going to see a whole set of mapping information that's available, alerting information that's absolutely critical. You need to bring together all the sensor information. You need to have operating procedures. You need to have resources being delivered. And you need to be able to look at plans and what happens in the future. All that disparate data is orchestrated together in XchangeCore, forming what we dubbed a long time ago the tree of incident knowledge. That's the basis for it, and there is no way that any other form of information sharing can accomplish what Web Service Data Orchestration achieves. So how do you make it? How do you make it happen? How are we going to make this common operational data shared among everybody? Well, it starts with data standards. The XchangeCore web services are all designed to answer those common operational data questions. Each one of those web services that you see listed on the right incorporates a set of standards. so that we're able to compose each one of those, which is an individual. So think of that as where I go to get my silo of information about sensors. Or where do I get to go my silo of information about alerts or about GIS? And compose them into my tree of knowledge. With each one of these being represented by we call it a share product or a work product inside of XchangeCore that allows me to compose my content packages from each of these disparate pieces of information. And those standards are critical. So I want to take a minute to review them. The incident work product is NIEM, the National Information Exchange Model. Consumes a couple of other things, the Law Enforcement Information Technologies Exchange Consortium, as well as Common Alerting Protocols, all of which we take because they're ways of finding out problems out there. And XchangeCore takes those and composes them into a NIEM incident. That incident creates everything that kicks it off. You then are going to, through the connectors, notify other XchangeCores and other applications, which you use WS Notify, another standard for notifying other organizations. Other standards that come from the Open Geospatial Consortium we use for our XchangeCore feeds, we use for our map work products, all of those basic standards that exist out there in the industry so that everybody knows how to go get that information. The sensors as well, the sensor observation service, people know how to get the information from XchangeCore using that Open Geospatial Consortium set of standards. That's what makes this not only possible, but readily doable by the industry out there because we're based on standards. Then there are a couple of emergency data exchange language standards, resource messaging for moving resource management around. Common Alerting Protocol has become an EDXL standard. And then there are three for which I will only call these emerging standards. Each one of them uses NIEM to compose a complex object, but nobody's actually sat down and created a standard for the Incident Command Systems forms, or the Incident Action Plan, which is composed of ICS forms, or for tasking. Those remain to be done. We've been working over the last few years on these, and I think we're probably approaching the XchangeCore community, now that it's running XchangeCore, probably approaching the point where we should be taking these back to NIEM. And that's one of the things that, as the XchangeCore organizing group comes into play in the fall, that you'll be learning a little bit more about, we'll be making decisions about that, so whether that's a valuable level of effort for the XchangeCore community is to propose these standards out as NIEM extensions. But every single one of these, either standard or a published evolving standard available on the XchangeCore website, now on the XchangeCore GitHub location, so that anybody can now take that information. You don't have to worry that there's proprietary data being secreted away in some application anymore. So those XchangeCore standards, or standards adopted by XchangeCore, critical to making all of the Web Service Data Orchestration and content packaging work. So what does this mean? Where's the value for you? What's that value in operational decision making? Let's take a look. Value is that you don't have 90,000 data layers. You have now focused on what matters and what's relevant to an incident. That incident sharing defines an area of interest that allows geospatial and non-geospatial tools to refine what they provide. I only want to know the 3 schools that are affected, not the 3,000 schools in the state. Secondly, Web Service Data Orchestration and XchangeCore makes certain that every application is acting on the same incident-related content. Because of the notification structure, every application that's connected to an XchangeCore is going to be notified whenever anything changes. So I know that every application has current and identical data, that they are simultaneously available to all the organizations using those applications through those notifications, that the data is continuously accessible on demand. At any time, an application can poke XchangeCore and say, give me what's new. That information is translatable to the application because when it sits in XchangeCore, it's already been translated into an international standard. And that content is shared by rule. You can't just log onto XchangeCore and say, give me some information. There is a structured rule relationship between XchangeCore and its connected applications and other XchangeCores that make it certain that the provider can know who the consumers of his or her information are. And the last point, the value of the content package, is that we consolidate non-geospatial information around a space. There's an awful lot of stuff out there that isn't geospatial. A common operating picture throws that away. I have an emergency plan. It's not going to show up in my common operating picture. I've got a checklist that people are 6 items through 12 items of the way through. A common operating picture doesn't make that available to me. Certainly not on a dynamic basis. What Web Service Data Orchestration does is take those non-geospatial pieces of information, associate them with one or more incidents that have a known location, and thus consolidate them around that space. What that allows me to do is far better understand the relationship among all the activities that are taking place during an incident. And what's that look like? Well, in a step-by-step fashion, start on the left-hand side and say, those are all the, what are they, hospitals or something. All the dots are in the state of California. And an incident is created and provided to XchangeCore by some third-party application. That incident then gets exchanged to other applications with that geographic location. In this case, this illustration, the line, the little dot down at the bottom right-hand corner with a star on it, is the centroid, or the center point of that earthquake, and the earthquake fault works its way up that line in the center on the bottom right-hand side, over here, to illustrate, if you can see my cursor. Consuming applications take that location information and can then select appropriate data. In this case, and this is NASA's Jet Propulsion Laboratory, this is something that operates all the time, that line of the earthquake fault was then used to find critical infrastructure out of the HAZUS database, critical infrastructure that's within 10 miles of that earthquake fault, thus providing appropriate data. The model results are then exchanged back to XchangeCore, and authorized applications are then notified of those results with exactly the same involved data that's right there. And I, instead of seeing all those dots on the map on the left-hand side, see that critical set of information on the right-hand side. That's the practical example of what a content package is. So the result is not everybody sees everything, but you see the exact relevant points. When these points change, when they're reviewed, in this case, the California Earthquake Clearinghouse is out there saying, hey, I just went to this dam and there's no problem at all, you're going to see that current status information become part of this content package. knowing that everybody has simultaneously viewed the same information. There's the value. And the value works its way through this XchangeCore orchestration lifecycle. It starts up in the upper left-hand corner, that green dot. We're bringing in data. Geospatial web services or non-geospatial web services or non-web services or API. Any of those data sources come in. They're translated and transformed in the blue arrow. Moving across the top, we end up with common operational data that's arrayed on the tree of knowledge. Content packages are then composed by all the different applications as they associate their data coming into that content package. Agreements, pre-existing agreements and dynamically created agreements, determine who the approved consumer applications are. Those consumers get notified in order to make certain that they have synchronized their content. And that view that we just saw allows applications to process, visualize, and improve their data. And when they do that, and they have some new thing, they expose that data in its native format. It becomes a brand new green circle there, data source, and it becomes part of the next translation, transformation, and the next unit, next application sees that as brand new common operational data. It's arrayed on the tree of knowledge, and the cycle continues. That's what Web Service Data Orchestration is all about. The results are I have all that valuable information orchestrated together, viewable from an on-scene activity in the upper right-hand corner to dispatch down the bottom right-hand corner to the bottom left-hand corner, my on-scene command, up to a state emergency operations center. That's where all the different applications that are used at all those different levels are able to secure the appropriate content to make the decisions that are valuable to them. So we have cut across all those different echelons and all those different, that are all your one of all those 12 different components, and allow you to compose content from those packages into any application to support the decisions being made at all of those different levels. So what's the next generation look like? I want to whet your appetite with XchangeCore 2020. It's the future of critical information exchange, and it's available now. We're going to be looking at this over the next couple of weeks, but just wanted to let you know that this is a major new release of the software. It will be all available as our open source, community-driven repository, so that people will be able to pull the XchangeCore down, modify it to their own purposes, submit those great innovations back, and share them among all the XchangeCore users. In the coming weeks, we're going to be hearing from the state of Queensland, Australia, that has created some new technologies around XchangeCore and is sharing them back into our open source repository so that all of you can evaluate whether that's a great new addition that you want to play with. We're going to be hearing about a set of shared data from the state of Florida that has taken XchangeCore information and is now putting it directly into ArcGIS. Have cut out all those other components, and you're now building ArcGIS map server data directly out of XchangeCore. We're going to hear as well about some new REST information interface software that has been provided, that again by Australia. And we're going to be hearing about some open source new components that allow you to talk in very different ways from to a WebEOC that were done by the state of California. So lots of new additions onto the XchangeCore of the future, XchangeCore 2020. And one of the best bets about this is because we've lowered the barrier to beginning operation with XchangeCore. Because of the ability of XchangeCore 2020 to operate as a cloud service, the XchangeCore community will be hosting XchangeCore in the cloud. Your access to it will be at no cost. It will be complete and operational. XchangeCore Virtual Core is yours. We welcome proof of concept projects so that you can use existing XchangeCore connectors and get started really fast. We welcome an initial operating capability where you can use the XchangeCore community virtual cores until you're ready to assume full operation. You're going to be able to use those as part of the XchangeCore community virtual core. You can then evolve that out to a cloud-hosted XchangeCore with any of the XchangeCore community partners, or you can then go off and do your own installation of XchangeCore on your cloud or your private network. But to get to that point, barrier to entry is zero. No cost. All you have to do is participate through the XchangeCore community in the XchangeCore cloud service. So those are some very exciting things. That's what the rest of the fall is going to focus on, is getting you up and running and people talking to you about what they have already done in delivering XchangeCore to their clients.